differences. Do we have any tests soon? We will have a couple next week, most likely. I do not have one scheduled for today. It doesn't mean you can leave though, because there may one of those quizzes we have next week may have something to do with what we do today. You might want to consider that. So there's still quite a few people haven't showed up, so we're going to give them a minute. I'm going to try and get this camera functioning the way I want. So let's see. Wow, it is freaking out. That is terrible. Savannah, AJ, Micah. All right, there's still quite a few more people. So I'm going to hold off for a second. Make sure this camera's working the way it's supposed to. Come on. What is the deal here? It's not even focused. So it's just not acting the way it's supposed to. What is wrong with this thing? Okay. All right, so we're gonna go ahead and get started. If somebody comes in late, they may have to wait a little bit to get let in. But so I don't know why this thing's not focusing. Is it dirty or what? Doesn't seem to be. Okay, so what we're going to talk about today is laminating, all right? And specifically laminating for the top of your nightstand, all right? So, wow, this is terrible. So basically, I have a couple boards. Your nightstand is, well, being made out of pine, so you know, I don't know if you do that. But we're going to move this camera this way a little bit. That is just, I've never seen it move like that. That's terrible. There's somebody else coming in. Wow, it does not want to work, folks. What is wrong with this thing? It's all out of, does it look fuzzy to you guys? Look out of focus? That's terrible. It is not functioning very well. It's out of focus. Let me make sure it's not dust on the limb. I don't think it is. But you never know. Well, I didn't mean to move it. Moved it. Wow, it's doing some really weird things. Well, we'll have to deal with it the way we have it, okay? There's somebody else coming in late. Damn. All right, I'm just not gonna let anybody else in right now. I got so much I need to get done. So here's what we've got, okay? Depending on what we need, according to the plans, is, let me grab them. We need our tops final dimensions to be 3/4 thick by 13 3/4 wide by 16.5 long. So what we're doing is we're laminating for width, all right? So, these out of the way for now. So depending on how wide your existing boards are, will determine how many you need. For example, these boards are right at 10 inches wide, so 2 of them is going to get us where we need to be, okay? So one of the things you want to take time to do when you're laminating is to lay your boards out like they're going to be glued up and take a look at the grain, take a look at the color, things like that, and see what matches. Turn it, flip it, whatever you want to do. Okay, that's not too bad. All right, and lay it out how you want it. So once you figure out this is how you want it to be, put it even end to end. I'm going to mark it like this. Okay, I'm going to go ahead and put a 1 on this because I'm doing the same thing for next period, so I'll be able to tell them apart. All right, so now if we were doing a larger tabletop with multiple boards, we'd want to make sure and take a close look at the end grain. All right, so for example, this end grain is going this way, it's cupping this way. See if I can describe this to you guys. When the end grain is going like that, when it's cupped like this, okay, in other words, your boards, your end grain looks like this, it's going to warp the opposite direction, okay? So if we were doing multiple boards or a large glue up or something like that, big tabletop or something, we'd want to flip every other board so our end grain was opposite on every other board. That will help even it out. If we put it like this and our end grain on both boards go in the same direction, the whole top's going to warp the same direction. If we flip every other board, it's going to tend to even itself out when it comes to expansion, contraction, warping, things like that. We've only got 2 boards here. They're on a little nightstand. It's not that big a deal, so we can do it like this, okay? So that's how we're going to glue it up. Now, we need to get this prepared for glue up, all right? So, first thing we need to do is joint the mating edges of the board. We want to joint the edges. They're going to be glued up, okay? Wow, there's something seriously wrong with this camera. And I'm hoping it's not. Let me make sure there's not a bunch of stuff open here. Okay. Well, we're going to have to hope it does it. Okay, I'm going to actually turn this off for a second, then turn it back on. That'll give me time to let a couple people in that have come in. Paint. Isaac. All right, let's try to turn it back on, see if that helps at all. It's been running all day. Come on. It's got to do a little startup procedure, or at least it used to. What's going on? There it goes. It's doing its little thing. That'll help. Okay. Yeah, Tyler, I'd actually like to, but the camera either works or it doesn't. And that would also require me to be here twice as long, because that means I have to be here for every class and then be here for every class's outside of class video. And I just don't have time. I wish I did, I wish I knew how to edit videos. I could make them a little nicer. And for some reason, this thing is not working. So let me try one more thing. Okay, so it's working there. All right, here we go. Let's try this again. Wow, that is crazy zoomed in. That's much better, much better. Okay, so we've got our board sitting here. We've got it ready to go. We need to joint those two mating edges, okay? So we're gonna move this over to the joiner. I'm sorry, I didn't have time to preset any of these like I usually can. Okay, so on the joiner, we're just gonna joint these two mating edges, okay? This edge right here, right? And this other edge is gonna be glued to. We don't need to worry about doing the other edges, the opposite edges. It's not doing pretty good. So, listening to see, listen for a consistent sound. I'm gonna one more pass. And grab our other board. Let's see what it looks like. Should have a nice, tight joint right there with no gaps. Should be just perfect, okay? Now that we have it, we've got it glued. And I don't usually glue on this table, but it makes it easier than having to move the camera all the way over to the glue table. All right, so we're gonna mosey back over here. Okay, come on, go down. All right, so I've got glue, I've got clamps. So basically, anytime we're getting ready to assemble anything, whether that's gluing two boards together, whether that's assembling a drawer or a cabinet or anything like that, any time we're going to assemble something, we always do it dry first, no glue. And the reason for that is we want to make sure everything fits together the way it's supposed to without any issues, okay? Because once glue is on it, there's not much we can do about it, okay? So normally we'd have these clamps in a table we have over the other end of the shop. It's got little slots in it to hold the clamps in place. But I don't want to deal with moving the clamps over there, so we're just going to do it right here. So the first thing we do once we get our board set in here is we want to set up the clamps, okay? First things first, we give ourselves about an inch of threads right here so that we can back this off so we have enough room to tighten it down. Then all we have to do is slide these back pieces up, okay? And our clamps are set, they're ready to go, okay? So boards look good. It looks like we're real good. We've got no gaps, nice. So now we can back these off a little bit. Okay, we can stand one up. We can take a little bit of glue, and I'm actually gonna brush this on. I don't want to use too much glue because I don't want to get glue all over this table. Usually what I do is I just take the glue bottle and pour a bead of glue on it and slide it across with my finger, but I don't want to make a huge mess here. So we're just going to take a glue brush, a little piece of scrap wood. We're going to brush the glue on real quick. Okay. It doesn't take a ton of glue. We shouldn't have glue pouring out of this thing when we clamp it up. It's just a waste of glue. It makes a huge mess. It's just not worth it. And we only have to glue one surface. We don't have to glue both surfaces. Okay. So we get glue on. And there we go. We've got a good layer of glue there. All right. Lay it back down. Get it lined up. Now, this is a pretty slippery surface. Okay, so if I sit here and I just tighten one clamp, a lot of times the boards are going to shift like this. So I like to just pressure on the clamps. Doesn't take much, okay? It does not take a lot of pressure. You're not using clamps to close gaps to make things fit. You're just using clamps to hold it together long enough for it to dry, okay? So I don't know if you guys can see or not, but there's a really nice little bead of glue all along the joint. That's good. I've got good glue squeeze out where I want it. We'll take a look at the back. You guys can see the glue squeeze out, I think, on the back of it. If I set it down here a little bit. Okay, you can see a little bit of glue squeeze out along here. That's what we want, okay? So I'm gonna set this aside. All right, through the magic of, well, coming in early and staying late and making extras, here's what I have, okay? So this is, let me come over here and so you guys can see this. I'm gonna zoom out just a little bit. Okay, so what we have here, all right, is a board that I already glued up, okay? It's rough dimensions. Oh, I got 3 people waiting to get in. I should make them wait, shouldn't I? This is just... You guys need to get here on time, please. This is really annoying. I understand if your computer drops you out or anything like that, but if you're just late, it's not cool. So here's what we've got. It's rough dimensions. In other words, what I'm saying is it's a little bit wider and it's a little bit longer than it needed to be when it's done. We always glue boards up a little bigger than we need, okay, as a final product. So this thing's supposed to be 13 3/4 wide by 16.5 long when it's done, right? Right now it's, well, it's 13 3/4 right at it. Oh, actually, it's got a little bit more. It's got a little bit more. So we've got a little room to clean it up. All right, about a little over a 1/2 inch over, okay? So we're gonna take this down to 13 3/4, okay? I've already jointed one edge, okay? In fact, I've got a little pencil mark here, right here. You can't see it, but that's my jointed edge right there, okay? So I'm gonna put the jointed edge against the fence. I'll rip it to width, and then we're gonna cut it to length, okay? So we'll get this up a little bit, zoom in a little bit. All right, so we'll rip the width first. There's our jointed edge. It's against the fence. $13 3/4, locked down. Sanded left of the blade. Tight against the fence. And off the table. All right, so we've got our width. Now we need to do length. Normally we go to the miter saw to do length, all right? This board's too wide to cut this to length on the miter saw without having to flip it over and make a second cut, and that's not very accurate, but we do have a way to do it, all right? And how we do it here is with a cutoff sled. Let's clean this out. Okay, so we have this cutoff sled. Very dusty. And this is basically what it is. It's got a couple runners on the underside. Okay, these 2 metal runners right here that fit into the miter slots on the table. All right. We drop it in. Okay, we are going to raise the blade because the board's sitting up higher now, sitting on this sled. Blade's about a 1/4 inch above our material. So here's something about cutting to length, and this works the same way whether it's on the miter saw, whether it's using this sled, whatever the case may be, okay? No matter what. When we're dealing with solid stuff, pine, oak, poplar, cherry, maple, alder, it always takes 2 cuts to cut a board to length, okay? Since this is solid material, we don't know how flat, straight, and square this end is, okay? So we have to square one end before we can go cut the other end to get it to final length. So there's always 2 cuts to cut a board to length. So our first cut, we're just trimming enough off one end to get it flat and square. Okay, so we take this, set it right up to the kerf, turn it on, hold it tight up against the fence. And trim one end, okay? So, excuse me, this end was just trimmed flush, straight, and square, all right? So we're gonna turn it around. Using the other end, we're gonna get it the final length of 16 and a half. So I'm gonna make a little mark right here at 16 and a half at the leading edge of my board. So I've got a little here. I'll go ahead and draw a line so maybe you guys can see it. I don't know if you can see it on this camera or not. So here's our length right here. Okay. So all I have to do is place this line right on the left side of this curve, this groove that exists in this board, because the blade is what made it. I wish you guys were here to see this. It'd be a lot easier to understand. I'm going to set it right there. And we're done. Cut to length, okay? So this is our pretty much completed top, okay? We've got one more thing we have to do to this before we can mount it. We're going to put a decorative edge all the way around it, okay? So the first thing we want to do is we want to figure out, and that's the wrong way. I didn't have time to preset this. We want to figure out which surface we're going to use for our top. What do we want to see? Do we want to see this side, or do we want to see this side? Personally, I think this side might be a little nicer, okay? So this is going to be our top, all right? And I want this to be our front edge, okay? We're going to number these. We're going to flip it over. We're going to put a 1 here. We're going to put a 2 here. We're going to put a 3 here at the front edge. We're not going to route the back edge. We're not going to put a decorative profile on the back edge. Only the 2 ends and the front edge, okay? And then one of our rules in here is whenever possible, which is pretty much all the time, we always route end grain first, because when a router bit exits end grain, it tends to take a chunk out of it, okay? So if we do the ends first and a chunk comes out over here, when we do that edge, it should clean it up. So let's take a look at what we're doing on the router table. Let's go ahead and mosey over here. So you guys haven't really seen the router table at work or anything like that yet. So this might be interesting. All right, let's zoom in on it. Volumes cutting end, not in, end. Here, that's a good question, Tyler. That's a very good question, actually. All right. So, let me turn this so I can see what I'm showing you guys. When you look at a board, okay, like this, any piece of lumber, well, solid stock, okay? That's how it was in the tree, vertical like this, okay? So nutrients, moisture, things like that, everything that came from the roots to go up the leaves goes in that direction, okay? It's like, imagine this being a bunch of straws, okay? And all the moisture, all the nutrients, everything go through those straws to get to the leaves in the tree, all right? That makes this end grain. In fact, if you took a nice magnifying glass or a real weak microscope, you can see the little cells in the end grain, okay? So the reason we try to differentiate between face grain, edge grain, end grain, and end grain is because all these different surfaces react differently to cutting tools, to router bits, to stains, to glues, things like that. The end grain is going to soak up a stain a lot more rapidly than the face or edge grain will, because that's the natural pathway for nutrients in a tree. Glue, we have water-based glues. You put glue on the end grain of a board, it's going to suck the moisture out of that glue. It's going to be a weak joint. It's not a strong glue joint. When you try to hand plane or use a chisel on or route the end grain of a board, okay, you're taking a good chance on it tearing out. Let's see if I can show you something on the jointer about going the wrong way with grain, okay? So one of the rules we have in here is we do not joint end grain. Okay, so I'm going to take a piece of material. If I can find a decent one here that will work. That's pretty good. Okay, so here's a piece of red oak. All right. So this is the end grain on the board. This is the edge grain. This is the face grain. Okay. We generally only joint edges and faces in here. We never joint end grain. And if you do joint end grain, let's see if it'll do it. Sometimes it happens. That's usually what happens. Okay. It tears out really bad. Okay. This is where the joiner head, the cutter head, exited the board. So that's one of the reasons we don't joint end grain. It's not the best way to get that end flat, straight, and square, and it usually takes a big chunk out of the board as it exits. So that's one reason we don't do that. Okay, so the router table is very similar in that we want to do end grain first. Let me move this over there. That's the wrong way. Okay. All right. So the thing about router tables, routers. This is basically just a 3 1/4 horsepower router mounted upside down in this table. You might be able to see it. If I can tilt this up, you should be able to see it. I don't know if you can see it or not. There's a router motor right here, router under this table. Okay. Now, what's interesting about a router, if you guys remember on the CNC, there are a whole lot of different bit choices on the router. Okay, so the router is basically what we use these router tables for most of the time is putting a profile or a decorative edge on a board. And the choice of bits we have to do that are basically limitless. This is a chamfer bit, a 45-degree chamfer bit. This is a 1/2 inch roundover bit. Okay, this is a 3/8 roundover bit. So this is the one we're going to use right now. We're going to put a different bit in the machine. It's not hard to do. First of all, we have to get this thing up where we can get to it. Okay. There's our bit that we currently have on it. 1/4 inch roundover bit. We're going to take this out. Drop this other bit in. Now, a lot of these bits, depending on the height that you set them at in this table, can do more than one thing. And I'll show you what I'm talking about. This is a pretty good bit to use an example for. All right, come on. All right. Now, these routers, being a 3 1/4 horsepower router that can be run at about 21,000 RPM, they are powerful. Respect the router, basically. So what I want to do is I'm going to do 2 different profiles on this thing. The first one, I'm going to do a simple, I've got to change that insert. I'm going to do simple roundover and show you that this bit can do 2 different things. All right, so I need to set the height. There's our height for a simple 3/8 roundover. So on the router table, we always go from right to left. In other words, we want to go against the rotation of the bit. So I'm going to set this bearing guided bit. There we go. Flush with the fence. We always want to go from right to left. And we always want to use push pin. Okay, so I'm going to put this face down on the router table, and I'm going to go number 1, then number 2, then number 3, and we'll see what that profile looks like. Okay. So I don't know how well you guys can see that or not, but it's just a simple round over, okay? That's all it is. Now, if I raise the bit a little bit, I'm gonna raise it up. What we're doing is exposing. See if you guys can see this. So right now, all we really used so far was this little rounded portion of the bit, but there's a flat side to this bit too that's got a cutting edge on it as well. So basically what I'm going to do, I raised it up so some of that flat portion is exposed. So now it's not just a round over. What's called an OG. That's not truly an OG. But, so we've got it raised up, flip it back over, the same order we did. 1, 2, 3. So now you should be able to see the difference in the profile, right? It added this little flat raised looking portion, okay? So depending on how high certain bits are, how high they're raised, okay, will determine what kind of a profile it will give. So we didn't do anything to the back edge because most of the time these nightstands will sit flat against the wall. So we've got a flat edge. All we did was the front edge and the 2 ends, okay? So hopefully you guys can kind of see that. What we're gonna do to this top next before we mount it, okay? We're actually gonna do a laser pattern on this so you guys can see how the laser works, all right? So we're not gonna mount this today. We're gonna get this thing ready to go for the laser, which means I have to find something that I wanna burn on the top of it, which means I don't know what I'm gonna use to put on the top of it. Pine generally, different woods react differently to, oh, I've got somebody trying to get in here. What do you know? Yeah. Okay. So, ingrain, I got that. Lag. Okay, I'm trying to look at some of the questions people had. I like questions, so I want to answer them. When you get lumber, do they mark which side's the ingrain? No. Tyler, once you're in here and you're looking at lumber, even for a week or so, you can very, very easily distinguish ingrain from edge grain from face grain. It's a piece of cake. As soon as you look at it, you'll know. Most of the time, the ingrain is going to be the smallest surface on a board. Okay, and let me see if I can show you what I mean about that. If you guys were here, there's a whole class period on face grain, edge grain, and ingrain that it's just really difficult to run without you guys here. But we'll do the best we can. Okay. So here I am. There's my bald head. All right. So basically, usually, not all the time, but usually the end grain is going to be the smallest surface, right? This is like the largest surface on this piece of wood. That's face grain. Usually that's how it's going to be. This is edge grain. This is the second largest surface area on the board. That's usually how it's going to be. And then the end grain, okay? If you look at, here, let's take a look over here. That's the wrong way again. If you look at our lumber rack behind me, okay? All this stuff with the paint on the ends, all the pieces sticking up, this is all end grain I'm touching here. This orange part, end grain, end grain, end grain. End, E-N-D, as the end of a board, okay? So end grain might help instead of me saying end grain, okay? So, yeah, router table is very, very loud. So that's basically how we do the top, okay? We laminated for width, okay? In other words, glue it together edge to edge. Then I thicknessed it. All right, I ran it through the planer, then I ran it through the drum sander to get it down to final thickness. Okay, then I joint one edge. All right, then I go to the table saw, I rip the opposite edge, getting it to final width. And then normally in the length category, when we go to cut to length, we'd go to the miter saw, but these are a little wide for the miter saw. So we ended up cutting to length on the table saw using a cutoff sled. Okay. So that's our order of operations in the shop. We always do thickness first, then we do width, then we do length every single time. That's how we do it. In beginning woods, we do it every single time. Thickness, then width, then length. That's just the way it goes. That's how we do it. All right. So let's see. What am I forgetting? Have I forgotten anything? So when gluing, you want in grain to be for routing. Okay. How do I answer this so you guys really understand it? Okay. The reason we choose to route one surface before another or one surface after another is the way in which the material reacts to a cutter. For example, I showed you guys that if you take in grain and run it through the jointer, it's going to take a big chunk out when that board exits the cutter head. The same thing with a router table. End grain reacts differently to a router bit than edge grain does or face grain. Okay. Normally, 99% of the time, when you route edge grain, okay, it's going to route nice and clean. You're not going to have a lot of tear out. Oak's kind of an exception to the rule. Oak tears out no matter what you do. But you're not going to have a bunch of tear out and splintering when you route edge grain. Okay. When we route end grain, can you guys see the grain going this direction in this board? Okay, that tells me that this is end grain and this is end grain. Okay, and the size of the board tells me that this is edge grain and this is edge grain because the face is the larger surface. Okay, but when you route end grain, okay, you can actually, I don't know if you can see it or not, but right here, let's see if you guys can see this. I'm going to look and see it. Okay, it's probably not going to focus on it, but I'm trying to show you that it did tear out a little bit right here. Okay, there's a little chunk taken out right here because the bit, when that was done, the bit went this way along the end grain, and when it exited, it caught that end grain or caught the end of the straws, grabbed it, and tore it out. Okay, so imagine this is a bunch of straws, right? And the straws are all running this way along the length, following the grain, right? Okay, it's going to be rough if you run your finger along the end of the straws. It's going to be smooth if you rub your finger along the edge of the straws, right? Well, that roughness, that end grain is what gets caught by bits, hand planes, chisels, anything you're trying to cut on these guys. Okay, so it's just one of the properties of the material that you work with. There are things you can do to help prevent or at least diminish tear out. You can use a backer board. In other words, if I was routing this in grain, I can take another board and place it right here so that when the bit exits, okay, it's got something to support the wood grains there on the end of the board. It's going to mess this up when it exits, not this. You can take small passes on the board. You can lower the router bit, make a light pass. You can make 3 or 4 separate passes, really light passes. In other words, taking off a minimal amount of material. And that tends to sometimes minimize the amount of tear out, as opposed to just taking all the material off in a single pass. That's a lot of material to take off. It can take a big chunk out of the end. The type of material, the species of material you're using can play a part in how badly it tears out. Oak is kind of notorious for tearing out. You know, pine's generally soft enough where it's not a big deal. The sharpness of your bit matters. If there's pitch buildup on the bit, things like that, a lot of different things can make a difference, okay, and as to how things route and how things react to cutters. So hopefully that helps a little bit. When you guys do finally get back here and you're in the shop, it'll be a lot easier to explain these things to you and physically show these things to you so you can hold them in your hand. If you have, what you can do is at home, take a look at your kitchen cabinets in your kitchen, or take a look at the cabinets in your bathroom or something like that. And there's going to be a door on the cabinets that sits like this and opens like this, right? So what you're looking at with the cabinet door closed is you're looking at face grain, okay? The edges of the door is edge grain, but the top and the bottom of the door are going to be end grain. If you look at a piece of furniture in your house, if you have a coffee table in your house, as long as it's solid wood, if it's not solid wood, it's going to be almost impossible to tell because they put this fake stuff all the way around the edges. But if you have a coffee table or something like that at home that's made out of solid wood, or at least the top is made out of solid wood, look at the ends of the coffee table, okay, and compare them to the edges and the face. You'll be able to tell by looking at it that the end grain looks distinctly different from any of the other grain surrounding that top or that door or that piece. Okay, so take a minute at some point in time and look. That'll help you to understand. So in gluing, you want end grain. So when you glue, we're gluing edge grain to edge grain for these tops. We would never glue end grain to end grain. We don't have the tooling necessary to make that a viable joint. Okay, there's not enough surface area, and end grain doesn't glue very well because it sucks all the moisture out of the glue, and it's a weak joint. So the other way we glue is face to face to make a thicker board. So we can actually glue boards together face to face and make a thicker board out of it. We do that for legs a lot of times. The strongest wood that we work with is probably maple. We have the maple we have here, and strength is a relative term. But the maple we have here is what students would choose for things like cutting boards, things that are going to take some abuse, things like that. Oak is pretty dense, pretty hard. Cherry is fairly dense and hard. The alder we have is, I'd say, just a little under cherry in hardness. And then poplar is the next to the softest wood, and then pine is our softest stuff. So things like pine, poplar, and alder, I would never recommend for a cutting board or something that's going to see a lot of abuse, a tabletop, things like that, that's going to have a lot of abuse. Wouldn't be a good idea. So yeah, Alexia, you said something about hickory. Hickory is a really popular cabinet wood right now for kitchen cabinets and things like that. In fact, my brother's just building a house, and all his cabinets are hickory. A lot of variation in color in hickory. Hickory is an open grain wood. In other words, you can take your thumbnail and you can slide it across the surface of the wood, and you can feel the grain in it with your thumbnail or your fingernail, as opposed to something like cherry or maple that's a closed grain wood that has a much smoother surface. Hickory and oak are two of those woods that would be very difficult to paint because you can still see the grain through the paint. If you're going to paint cabinets or something like that, people generally use maple or something like that, a closed grain wood, so you can't see the grain in under the paint. So that's what sucks about my cabinets at home, is I'd like to paint them, but they're oak, and it would be just a royal pain to go through the process of filling all the pores before prepping for paint. So it just wouldn't work. Okay, so I hope you guys got something out of that. I hope I wasn't too confusing and over the top and not getting you guys the information you need. So it's Friday, which means you got 2 days off. Thank you for being here. Please try to be here on time on Monday. It's very helpful when we're doing these things. Take care of yourselves, and I hope to see you guys Monday. Make sure your name is in the chat window for attendance, and you guys have a good weekend. Okay, bye-bye.